TDD, I'm not going to get too much into intro stuff or describing it. You can Google it if you don't know what it's all about. I'm a firm believer of actions over words, so without further ado, let's start. Let's say we have this very, very simple requirement of we need to write a server, an HTTP server that responds to HTTP requests with the simple, classic hello world response. So this is the TDD way of doing that. So I'm going to start with a test. The way I'm going to do it is by writing an end-to-end test first. I'll define a Java, and by the way, this is going to be in Java because it's kind of like general purpose language that everybody sort of knows. I'm going to define the greeting server E2E test. And by the way, I'm using JUnit for this, which is kind of common. So step one is greeting with hello world. In order to do that, I'm going to start up my server, which doesn't really exist yet, right? So I'm just going to write the code that starts the server from the outside. I'm going to treat it as black box as I can. So here goes. What I've done here is define this greeting server class, which doesn't really exist. And I'm going to get it to compile first by letting the IDE generate the code that's missing. And now the next complaint is that there's no main method, and I'm going to let it define it. And in order to be able to run it from the command line later on, I'm going to define these args as well, which is the standard Java way of defining an executable code. Okay, next step is I want to execute some sort of an HTTP request to this imaginary server that I've started and assert against the response. So let's see how I can do it by using this little template that I've written. I'll go over it soon, but basically the idea is I'm just using the standard JDK tools, no external libraries, nothing fancy, just whatever is coming with Java. And I'm defining this URL at port 8080, and the endpoint will be called greeting. And this piece of code throws an exception, which I'll just propagate up and let the test throw it. So basically, what this line does is it creates an HTTP GET call, and I'm going to save it in the variable called response. And I'm going to assert that response is hello world. Now I have this basic test written, and now I can run it and watch it fail. And as you can see, we got a connection refused because there's no one listening at that port. So let's make that test pass by introducing the minimal amount of code necessary to make it pass. Again, I'm going to use this template that I've made here, which starts up a minimal, really small server using, again, canned Java technologies, nothing fancy. So I'm going to start it at port 8080 because that's what the test required. And I'm going to let that exception be thrown. Sorry. Oh, first I'm going to fill up the missing parts. I needed to listen to an endpoint called greeting, and the response should be hello world. Okay. Now, this little red line tells me that this code throws an exception, which I'll just throw out for now. Okay, so now I'm going to run the test again, and now it's passing. Okay, so we have our first feature covered. let's move on to the next one, because right now I don't see any reason to do any refactorings or cleanups. So next, let's say next requirement is when I execute the same get method and I have a query parameter called name, and let's say I'm sending name equals Sagy, the response should be hello Sagy. And the name of the method is should read by name. I'm going to run the entire test suite. And now you can see there are 2 tests failing, and the reason they're failing is because there's some issues with the occupied port. I'm starting the server twice from both methods, so I'm going to eliminate that by moving this little piece of code into a common method, which will be executed once. And I'll call it startup server. And again, I'm going to let the exception return outside. And now I can delete this one line that was repeated in both tests, rerun the test, and now I'm hopefully going to see we have one passing test and the new one is failing because of an assertion failure, which it says expected hello Sagy but was hello world. Doesn't really surprise us because the code returns this hard-coded hello world. So what I'm going to do is I'm going to complicate it just a bit, just enough to make this new test pass. Okay? So the way to do it is, I guess the simplest way to do it right now would be just to check if there's any query parameter present. I'm not going to do any more processing than is needed to just pass the test. So it looks something like this. Let's say that the response starts out as an empty string, and if the exchange, there's this get request URI thingy here with get query. Cool. So if this is null, then I'm basically on the first case, which is the hello world case, like this. Otherwise, the response should be hello Sagy, because that's what I expect to see in the test, right? Again, we have a green bar. Okay, now this is a bit more sophisticated, but really not impressive yet. And one of the problems is that it's only going to work for this one single scenario, which probably is not good enough. So let's see how I can make it more resilient to generalize it to support many different parameters. The way I'm going to do it is not by adding another end-to-end test. I'm going to try to prefer to write as many unit tests as I can, instead of then adding larger end-to-end tests. And the way to do it in this case is to change up the design a little bit and let the test, my need to test this very simplified logic, I'm going to let this test drive the new design. So basically what I'm trying to do is separate the HTTP elements from the rest of the core logic. I'm going to do it by extracting a variable which represents the query. Okay, so this is very basic refactoring, extract variable. I'm going to put it up here. And this piece of code is now pure logic, right? So let's see how I can extract a method object out of that. And I'll call it greeter. Now, what this does is it will create this line of code for me that defines this new class that is pure logic and completely detached from HTTP. So the way it's currently built, I don't like it very much, so I'm going to change it a bit and move it to here. I don't want it as a constructor parameter, I want it as a method parameter, and I can get rid of this and also this and define the query here. Okay. Now, next step, I'm gonna make another refactoring. By the way, I can rerun the test to make sure that everything's still working. Now, next step would be to move this class into a location where I can unit test it on its own. So this is done like so, and now this class is located in a different file, or a different separate place where I can unit test it. So here's the way I'm going to test it. I'm going to write a unit test for this class. I'll mark this method, and what I want to test is the greeting by name. I'm going to assert that when creating a new greeter and passing it, okay, I'll take care of that in a minute. So passing in name equals, let's say, Homer, which is different than Sagy, because that's what I'm trying to drive, right? Would result in hello Homer. So now I'm going to rerun the tests. I'm going to run the entire suite, and you see that the new unit test that I've written is now failing because it responds with hello Sagy. So if query is null, I'm returning hello world. I'm going to add another else clause here. So if the query, let's say, contains string, in this case, I want the response to be hello plus the result of splitting the query and selecting the rightmost element of the split. Let's see if that's working, and it is. Okay, so now the code is a bit more general and supports any different kind of name that I'm going to throw at it. Now there's some edge cases that I can also check what happens if the name parameter is misspelled. What happens if it's there's lots, if it's an empty name, lots of different edge cases that I can think of, but I'm not going to do it right now because I have kind of a point to prove here. And so I'm just going to move along. And so let's say that we have this very sadistic product manager who wants this next feature. If you call the server between 2 and 4, you're going to get a different response, which is, I'm sleeping. I'm sure most of you know how to implement this feature, but given that this code runs in a CI system, in a continuous integration system, these tests would be repeatedly running every time anybody pushes any change to the code base. This means that those two tests that we've already finished are going to break between the hours 2 and 4, okay? And we cannot live with that. We don't want flaky tests or tests that are non-deterministic. We want them to be reliable, stable, especially if they're blocking us from GAing or releasing our code to production, which we do several times a day at Wix. So we cannot have these, flaky tests. So basically, what I need to do in order to make this, to solve this problem, is I need some way to control the time. Okay, so there are many different ways to solve these issues. This issue, I'm gonna show one, which works very nicely with this current situation where I'm testing the code from the outside as a black box, right? And I don't have this, I don't have too many options of manipulating the code, or introducing mock objects, stuff like that, because I'm testing it as a black box, right? So what I'm going to do is I'm going to introduce a new server, which would be the time server, okay? I'm going to start up the time server just before starting the main server. I'm going to use the exact same template that I've used before. Here it is. And I'm going to start it up on port 8081 because 8080 is already taken. And let's say it has an endpoint called hour of day. So we have two cases here, basically. One is when the hour of day is 2 or 3 or 4, and another one is when the hour of day is any other time. So let's start with, let's say that we want it to be 9 for now. Next thing I need to do is I'm going to write the new test. I've just started up a new server. Nobody's communicating with it yet. Nothing special. So I'm writing the new test that looks something like this. And I expect the response to be ZZZ. Okay? Now if you look, if you've noticed, I've taken the first test and copied it and pasted it and just changed the assertion, which means there's kind of a conflict between these two tests. So there's an additional element that needs to be changed in order to provide this requirement, right? And the additional element is setting the time to something else other than 9 o'clock. So what I need to do is I need to be able to create some sort of a mechanism to enable me to control this value. And I need my server to access this other server, because this is a microservice architecture, right? And using microservices is good. And I need to create this HTTP call from the server to the time server. And by controlling the time, I'm going to make the test deterministic, okay? So let's see how it's going to look like. So first of all, I'm going to write it. I'm going to run the test and watch it fail. But right now the value is buried here inside of the handler of the fake time server that I've just created. I'm going to pull it up into a common shared place where the test can control this value. So I'm going to introduce a field. Yeah, I'll start it in the field declaration. I know it cannot be static. Yeah, I mean, it cannot be final because I need to change it for the new test. And I'll still let it be initialized to 9 or whatever, but the point is, before executing the greeting request, I'm going to change it to be 2 p.m. So, and the name response is not working for me anymore. I need to change that to assumed hour of day, for example. So assuming the hour of day is 9, assuming the hour of day is 14, while executing this code, this HTTP request, I expect the result to be this one, as opposed to hello world, right? Okay, so first step, I've written this test, and I can, if I run this test, it will obviously fail unexpectedly because, you know, I expect it to fail because it still replies with hello world. But I see there's some code duplication here between tests, so I'm going to clean that up first, particularly this part where we execute the HTTP request. So here's the way to do it. Again, I'm going to use the same refactoring as before, extract method object. I'm going to call this object HTTP. That looks something like this, and it recognizes the code duplication, so it would do the same thing in the first test as well as the last one. And I don't like the name invoke. I'm going to change that to get, of course. And also, I need it to be parameterized because this isn't really working for me. I want to be able to control the URL because sometimes I'm going to pass in the name equals whatever thing. So this is done by introducing the parameter. So the name of the parameter is URL. If you look at the code now, it looks like this, which is much better. Especially, I can also turn that into a field and initialize it in the field declaration. And then I've removed most of the duplication. The only part, this needs to be removed as well. The only part that's not removed yet is this long line here, which I can now replace with calling the http.get. Okay, cool. Now running all the tests again, I'm in the exact same position as I was before, one failing end-to-end test, right? So let's go over to the greeting server and make this test pass, okay? I'm going to focus on passing just this one big end-to-end test. And the way I'm going to do it is, I'm going to query that fake time server and get the hour of the day and decide by the response, what should I return? Again, using the template from before, actually using the HTTP class that I've just extracted, I can reuse that. So I have this time of day that I can use. I forgot to extract that out so I can reuse it in the production code. I'm going to extract it out into a different file. And now it's going to be available for me to use here. So new http.get, and we're calling a server at http localhost port 8081, and it was, I think, hour of day, if I'm not mistaken. And once I have that in place, I can pass it over to the piece of logic that I've extracted earlier, and I can unit test that. Okay? So let's do that. I'm going to add it as a second parameter called time of day into the logic handling code. By the way, I can also change the name of the method from invoke to greeting, which makes more sense in our domain. I'll go over to the test, the unit test. And you see that now it's not compiling because I don't have any value for the time of day. In this particular scenario, I'm talking about non-lunch break hours, you know? So it's going to be, let's say 9, for example. Okay, so all of this preparation was just to enable me to write this new test. Still, I have a one failing end-to-end test. And I'm going to add another failing unit test to that would help me to drive the new feature. Okay, so sleeps at noon. I've expressed the exact same idea in a unit test. And now I should have 2 failing tests, which I do. And so let's do something like this. If the time of day is, let's say, if 40 equals time of day, then just return this. Rerunning the tests, I see that the new unit test that I've introduced is passing. But now let's see what's happening in the end-to-end tests. First of all, the new test that we've added that drives the sleeps at 2 feature is passing. But now the hello world, the basic scenario, the first test that we've added is now broken. And the reason is because of mutual state between tests. Mutual state between tests is a bad thing because it creates what is called temporal coupling. Or in other words, the order of running the tests matters, which we don't want. Basically, if you look at the order of the tests, you see that the test that set the time to be 14 got to run before the test that didn't even set the time. So it's using the default value of 9. So one test changes it to 14, that affects the rest of the tests. Okay? It's very similar. It's very similar to what's happening if you're testing against shared data or shared database. You have aliasing problems that one test affects the rest of the tests that run after it. So in order to eliminate this, I want to be able to, I need to change or make sure that the time is 9 for the 9 scenarios and the time is 2 for the 2 scenarios. So I'm going to do just that by heading over to the tests and changing the assumed time of day to be explicitly 9. And just for the sake of variance, I'm going to let the other one be defined for 10, just to mix things up. Running the test now will get me a green bar. So this solves the non-deterministic problem. If I would have accessed the time locally on the operating system, my code would be coupled to the operating system, and my tests would break whenever I run them between 2 and 4, which is unacceptable, okay? Now I wouldn't necessarily do that. In a real production situation, I might. And by the way, if you've heard of NTP, that's basically the NTP stratas. They work kind of like this, not over HTTP. NTP is a very, very old protocol that's been used since '84, and one of the first protocols of the internet that's still being used up until today. So it's not really NTP, but it's kind of the same idea. So it's not really that crazy, but I'm not sure I'm going to use this kind of solution for real production systems. There are other types of things that I could have done here, but this is just mostly to prove a point that when using end-to-end tests, I'm letting the end-to-end test drive my architectural decisions about which services are communicating with one another. When I find it hard to write my next end-to-end test, this usually means there's some architectural change that needs to be done, needs to be introduced, and I need to decide what it is and how to do it. Now, if I have trouble writing unit test, that usually drives my design decisions, okay? So to sum it up, end-to-end tests drive your architecture. Unit tests drive your design, okay? So this is the basic idea of doing the full cycle of TDD. One last thing I think needs to be discussed here is, I'll do it very shortly because I'm kind of out of time, the idea of drivers, because this code that you see here in the test code is very messy. It's just, a bunch of noise. And I want to clean that up. So the way to do that is by using what is known as drivers. Here's how it's going to look. I'm going to extract this code here into a driver class by extracting, again, a method object. It's very useful refactoring if you're using Java. And I'm going to call it fake time server driver or something similar. And it's going to look something like this. And so what happens here is that it extracted it into a static method for some reason, which I'm not going to get into. But let's do some cosmetic change. I'm going to rerun it just to make sure that everything still passes. Cool. Now, this method here, I don't want it inside the invoke method. I want to separate it into a different method. I'm going to call it start inside the fake driver. If I'm going to do that, you see that the IDE offers or forces me to pass in the HTTP server, which I don't like. So I'm going to change that. I'm going to undo this refactoring for now. What I'm going to do instead, what I'm going to do instead is I'm going to make this server a field of the driver class by doing alt F, or whatever, command F. And I'm gonna start it in the field declaration. So I can't do that. I'm gonna move it into a field, and I'm gonna start it in the constructor. And the reason I can't do it because it throws an exception. So now I will just let the exception fly out from the constructor. And next step, if I do the same thing, you'll see that it doesn't really, it just works. It doesn't need the server parameter because it's shared through the scope of the members of the class. So now I have this start method. I'm going to turn it into a public method. And I'm going to remove these static things from here. I'm going to remove this start method from start call from here. And I'm going to move this code that assembles the fake hour of day controller into the constructor. So now I have these this kind of a cleaner, cleaner class that I can use from within the tests. So the way I'm going to use it is by creating a new instance of the fake time server and calling start on it. Yeah, and hopefully everything still works. Cool. Now, assumed hour of day, this is the last thing I'm going to do here. Assumed hour of day is being referred to from within the driver and the tests, which I don't like. So I'm going to encapsulate it into the driver by introducing a method called assuming hour of day is. And let's say that it accepts an integer, hour of day. I'm going to have a member here that's called assumed hour of day, which is the string that will replace those external references. And I'm just going to set it here. Assumed hour of day is the stringified version of the hour of day. So last step is just change all these references to this of this variable into the referring to the fake time serial driver, which I now have to store as a field in the test class. So I have the fake time serial driver inside the tests. I can say assuming hour of day is 9, and rerun the tests, and now I have, okay, so I have, as a result of that, this is an incomplete refactoring. I need to, if I do the same here, because now there's an inconsistent state, some of it is referring to the variable, some of it not. By doing this, I hope, no, oh, the last one. So, okay, yay. So, dodge the bullet there. And as you can see, there's no references to this anymore, so I can just remove it. Okay, so let's quickly review the test code. Pretty much, yeah, it looks kind of okay. I could have maybe moved this into in another file just to make things even more clean. But yeah, basically this is it. And I don't know if I have any time for questions, probably not. So yeah, so that's it. Thank you.